All right, a quick one. We shall be looking at redox reaction. Redox reaction, very simple way of identifying reducing and oxidizing agent in an equation. It's very simple. Okay, this is redox reaction where reduction and oxidation are occurring simultaneously. Of course, you know reduction is the loss of oxygen, the gain of hydrogen, decrease in oxidation number, removal of electronegative elements, and addition of electropositive elements. Whereas oxidation is the loss of electron. Please remember, reduction is the gain of electron. Oxidation is the loss of electron, increase in oxidation number, okay, addition of electronegative elements and removal of electropositive elements, addition of oxygen and removal of hydrogen. So you should be conversant with all these definitions of oxidation and reduction. Now, generally in terms of electron transfer, oxidation is the loss of electron, while reduction is the gain of electron. Please take note of that. Now, if an equation is given to you, how do you simply identify the reducing and oxidizing agents? It's very simple. If such equation is given to you, first of all, take note of the one that is undergoing oxidation and take note of the one undergoing reduction. Now, anyone that is undergoing oxidation will become the reducing agent. Please take note. Anyone undergoing oxidation becomes the reducing agent. Anyone that is undergoing reduction becomes the oxidizing agent. Okay, so we'll put it as ROA, so we'll put it as OA. So please take note that any substance undergoing oxidation becomes the reducing agent. Anyone undergoing reduction becomes the oxidizing agent. So let's quickly look at this. Now, you can see that manganese is the major element here since it is being compared to manganese 2 ion. Okay, so how do we take note of the oxidation number of manganese here? What is the change in oxidation number of manganese? That is what will give you insight if it has undergone oxidation or reduction. So let's quickly, of course, you know how to calculate oxidation number. Please, if you don't know, in my next video I'm going to make a video on that. Let's calculate the oxidation number of manganese in that ion or radical. Okay, so we'll have so it becomes Mn plus 4 times minus 2, because oxidation number of oxygen is minus 2. I'm going to equate it to the charge on the ion, so I'm left with 4 times this will give you minus 8 equal to minus 1. So manganese, if you know how to do your calculation very well, 8 moves over here to becomes positive 8 minus 1. So the change in manganese is, this becomes oxidation number of manganese in this radical is plus 7. Okay, you see how I calculated the oxidation number. Remember, if you don't still know how to calculate oxidation number, if you're confused on how I arrived at plus 7, I'm going to make a video on that in my subsequent videos. Okay, so let's write down. That means manganese has changed from plus 7 here to plus 2. You can see the charge here is plus 2. So manganese in this radical has moved from plus 7 oxidation number to plus 2. So when something is moving from plus 7 to plus 2, has it increased or reduced? Obviously it has reduced. So manganese, this is undergoing reduction here. It has undergone reduction. Please take note, because I ascertained the oxidation number of manganese here to be plus 7. So when something is moving from plus 7 to plus 2, obviously it has undergone reduction. Yes, because I defined reduction as the decrease in oxidation number. You can see that there is a decrease from plus 7 to plus 2. Definitely it has reduced. Okay, remember what I told you, that any substance that undergoes reduction becomes the oxidizing agent. Since manganese here, this manganate ion has undergone reduction, definitely this is the manganate ion becomes the oxidizing agent. Please take note. Remember, any substance that is undergoing reduction becomes the what? The oxidizing agent. So in this reaction, manganese ion was reduced to manganese 2. So any substance undergoing reduction becomes the oxidizing agent. Now, once you ascertain one, the other one becomes very, very simple. Since you have noted that manganese ion was reduced, definitely ion 2 will be what? Oxidized. And what is oxidation? The increase in oxidation number. You can see that ion here increased from +2 to +3. Obviously, this is what? An oxidation process. This is an oxidation process. I hope you're following. And any substance that undergoes oxidation becomes a what? Reducing agent. So here, ion 2 is the what? The reducing agent. Did you get that? Did you get that? It's very simple. First of all, calculate if it is the one that requires you to calculate the oxidation number, just like I did. You calculate it first and then compare it with the other ion, similar ion on the right hand side. Okay, having done that, you check is the oxidation number increasing or decreasing. Here it is +2. You can see the charge on top is the oxidation number, while here I calculated it to be +7. Please don't use -1 as the oxidation number. No, -1 is not the oxidation number of manganese here, so you have to do the calculation to get +7. Compare it with manganese 2. You see that there's a reduction from +7 to +2. So that is why I indicated reduction here, and any substance that undergoes reduction is the oxidizing agent. Okay, yes, you can see any substance that undergoes reduction is the oxidizing agent. So that is why manganese ion, or manganese 7 ion is manganese 7 ion rather is oxidizing agent, whereas ion 2 is the reducing agent. With that comes to the end of our class today. Okay, before I go, please you can do this one and write on the comment section indicating the oxidizing and reducing agent. Indicating the oxidizing and reducing agent. This is chromium 3. Okay, chromium 3, chromate ion, ion 2, chromium 3. This is 3 plus, then plus ion 3. This is your assignment. Please do it. Ascertain the one that is undergoing reduction and oxidation, and state the one that is reducing and oxidizing agent, just like I did here. Alright, have a nice day until I come your way next time. Please don't forget to like, share, comment, and repost. Until I come your way next time, I still remain Chemistry Hour with Jenny. Have a nice day.